All right, I'd like to welcome you to the Module 32 video lecture. Today's topic will be on the issue of memory storage and memory retrieval. We're going to start today by looking at the different areas of the brain that store memories. One of the things you need to understand when it comes to how the brain works with memory is that not all memories are stored in one specific place. There are a variety of places in the brain that can store memory. Again, it depends on the type of memory. So keep that in mind as we go through this here. The first type of memory that we're going to look at here in the location are explicit memories. These are new memories. We should know already from Unit 3 that it is this structure right here, the hippocampus, that is involved in the formation of new memories. Think of it like the save button on your computer. When you're working on a document, you click save. That information, a new file is created. Your hippocampus serves as our save button for our long-term explicit memories. Okay? Our frontal lobe also plays a role in this as well. These are memories, again, that are explicit. We must have a conscious effort to form them, a conscious effort to recall them. We should also remember from Unit 3 that the left hemisphere of our brain tends to be more verbal, the right hemisphere more visual. So if we ask you to recall the name of your fifth grade teacher, that may be a long-term memory found in your left frontal lobe. If we ask you to visualize your fifth grade teacher, a picture, their face, that might be more of a right brain function. So it is our hippocampus and our frontal lobe that do play a role in these explicit memories. Now, you've heard me in class mention quite a bit the story of Clive Wearing. These were the two types of memories in particular that Clive Wearing did not have access to. His hippocampus was damaged through an infection, as well as portions of his frontal lobe. So he could not form new memories, and he did not have access to some of his older long-term memories. What he did have, however, were some of these procedural, or what we call implicit memories. And that's because there were two areas of his brain that were more or less left untouched by the infection. One was what we call the basal ganglia, which is just this region of the brain right here, and the other is cerebellum, which we know is located in the back of the brain here. So, for example, in Clive Wearing's case, he still had many of his procedural memories intact. He knew how to dress himself in the morning, how to feed himself. I mentioned he was a classical pianist. These are all procedural memories. A lot of times we use the phrase, it's just like riding a bike. We never forget these things. They are also implicit because we do not have to make a conscious effort to recall them. His cerebellum also was intact, so many of his reflexes, anything, and someone asked, would he be able to be conditioned classically or even operant conditioning? And the answer is yes, because our cerebellum helps us with a lot of this reflex type learning. So those two things were intact for Clive Wearing. As well as his amygdala, he did have some emotional memories that were still intact, especially when it came to his wife. He knew who his wife was. He knew that he loved her. And chances are those were due perhaps to some of the flashbulb memories that can occur. We know our amygdala is responsible, especially for our fear response, but as well as other emotional memories. Things that have high emotional content we tend to remember quite well. So the example here, of course, is 9/11. I remember that day quite well. I remember the first time I saw this picture, this scene on live TV of the towers on fire. I remember what it felt like when I saw those towers collapse. I remember the days following and what that meant. That was a flashbulb memory. I remember the day I was married, the day my kids were born. All of these have very high emotional content, and I will remember very high amounts of detail, perhaps until the day I die. This can be another reason why things like post-traumatic stress disorder can be very difficult to overcome. Think of Army veterans who've survived conflicts and combat. These things have very high emotional content and are seared into their memory, courtesy of the amygdala. So it's not like you can just flip a switch and forget these things. They're very powerful emotional memories. So this is just an overview again of the different areas of our brain where different types of memory can be stored. This is actually a good little review from Unit 3 as well. So this slide in particular you'll be able to access on Google Classroom when I post my notes. You have something similar in your book as well here in Module 32. All right, what we'd like to look at next now is the idea of what we call long-term potentiation, the process by which memories are formed in your brain. Take another trip back to Unit 3 when we talked about connections between neurons. Remember, there was the synapse where we had the axon of one cell meeting the dendrite of another, this space that we called the synaptic gap. Well, what happens when we learn something and a memory is formed? There are connections that are being formed between these neurons. In slide or photo A here, you can see one such connection between an axon and a dendrite of a neighboring cell. What happens with long-term potentiation, the more we rehearse that information, the more we study it, the more we practice it. Going back to our previous lesson, when we do deeper processing, what happens is that connection, as you can see here in photo B, gets strengthened, gets solidified, so that memory becomes firm and strong. If we don't practice, if we don't do deep rehearsal, the connection will still be there, but it'll be weak. So the idea of long-term potentiation between neurons, it is the biological basis for learning and memory. It is where it happens at the synapse between neurons. All right, what we'd like to look at next now is the issue of retrieval. So if that was storage and retaining information, what about retrieval? And that is getting the information out. Your book mentions 3 measures of what we call retention, 3 ways that we can retrieve information. The first you're probably most familiar with is simply recall. If you think of the memory exercises I've done with you in class up to this point, they've been recall. I've asked you to retrieve information that you were exposed to. Also think of like a fill-in-the-blank type of test question, maybe without a word bank. You're being asked to retrieve that information from memory. Another type of retention or retrieval is recognizing. Think of multiple choice questions. Here you may not have to recall the exact definition because you see examples there. You just have to recognize the best. Your book uses the example of yearbook photos here. You might be able to guess who these people are. This was before they became famous. On the left we have Taylor Swift, and on the right we have none other than Leonardo DiCaprio. It is likely that their high school classmates would be able to recognize them even if they had not become famous. We're very good, especially at facial features. Just the other day I ran into somebody at my son's karate class, someone who I graduated with from high school who I hadn't seen and since I graduated in 1992, but he was able to recognize me as a classmate, and once he said his name, I kind of put 2 and 2 together as well. That's recognizing. Okay? We can also relearn information. So think of this when we study for final exams. You know, you've learned all the material already, but at that point we're relearning it. Okay? Your book also mentions a very famous study done by Herbin Ebbinghaus where he basically tested himself in the memorization of meaningless syllables. So he would basically make up words. He would study the list, try to recall them. One of the things he found was that the more he practiced and rehearsed this list, the less time it took him to relearn it. So bottom line again, like we talked about yesterday, spacing out your study, distributed practice, the spacing effect is best even for relearning material. All right. What we want to look at now are some retrieval cues. These are some things that can help us when we're trying to get information out of our memory storage. The first one is priming. This is the unconscious activation of memory associations. You might remember in a previous chapter, I did an example with you where I said to look at the ceiling tiles, tell me what color they were. You said white. I said look at the computer screen, what color? You said white. I said look at the marker board, what color? You said white. And then I asked you, what do cows drink? And many of you said milk. Even though we know, unless you're a baby cow, you're probably not drinking their own milk. What happened there was I kind of set up your memory to react a certain way. We call that priming. Your book uses the example of seeing or hearing a rabbit. That's going to activate a certain mental image in your head. So then when I ask you to spell the word hare, you're probably going to spell it H-A-R-E, which is another name for a rabbit instead of H-A-I-R. This is priming. This is something that can either help or sometimes even hurt our memory. Another example here are what we call state-dependent memories. These are memories that are retrieved when we're in a certain mood or physiological state. So the condition mentally, emotionally, or physically that I was in when I learned the information can affect if I recall it. Your book gets into the idea of depressed people who have a depressed mood. They are likely to recall sad instances of their life. Why? Because that's the emotional state they're in. If they are not depressed and they're happy, they're likely to recall happy instances in their lives. So our mood and physiological state can affect our memory. The context which we learned information can also affect our memory. Here's an example of context-dependent memory. I'm going to go right to this slide here because it shows a good example. Here a study was done where they asked people to remember words or exposed to words and recall those words in one of two conditions, either on water, underwater, or on land. Here's what happened. When the person heard the words underwater and was asked to recall them on land, you can see the percentage that they got correct. Here's a condition where they heard the words on land, were asked to recall them on water. You can see the percentage here. Here's the same context. They learned the words or heard the words underwater and were asked to recall them underwater. Almost 10% better. Here's a condition where they learned the words on land and were asked to recall the words on land. Again, almost another 10% increase. So the orange lines here represent the idea of context-dependent memory. You will recall the word better when you're in the same context in which you heard it. Another retrieval cue here is what we call the serial position effect. Sometimes we call this the primacy and the recency effect. We know this. We are more likely to recall the first and the last items on a list the best. If I were to ask you, for example, to list the presidents of the United States in order, we would probably get the first few, Washington, Adams, Jefferson, etc., and the last few, President-elect Trump, Obama, etc. The ones in the middle, we're probably going to be a little fuzzy on, and there is a reason for that. If you look at this chart here, you can see the stuff at the beginning, the primacy effect, we easily remember because it's the first. Okay? There's nothing else to interfere with it or confuse us. Our minds are fresh at that point. The stuff at the end, which we call the recency effect, we can also remember because they're probably still in our short-term memory because they were the most recent. The stuff in the middle, we have the lowest recall, mainly for one of two reasons. Either they were presented too long ago to be in short-term memory, or so many items came before or after that there was too much interference and we could not transfer them to long-term memory. So the serial position effect refers to the fact that we remember the first, primacy, and the last, recency, the best. Okay? And back to our questions on the presidents. There they are in case you were interested in all 45, I guess now, of our presidents. All right, that's a wrap. Hopefully you've learned something from this. We will not be having a quiz on Module 32, but do make sure your reading guide is filled out properly. as you will be able to use that on the test over the weekend. Thank you.